Good afternoon, or good evening for some of you, and welcome to today's IWC's Urgent Communications webinar, TETRA and DMR Tier 3, which open standard digital trunking is right for me. I'm Donnie Jackson, editor for IWC's Urgent Communications. Today's webinar is being sponsored by our good friends at Sapura. I would like to remind you that if you have any technical difficulties, please press the Help button on your player console to receive assistance in solving common issues. For audio or slide advancement problems, try hitting the F5 key on your keyboard to refresh your webinar console. Use the Command and R keys if you are on an Apple computer. You will notice a toolbar at the bottom of your console. These widgets allow you to open and close widgets on your screen. For example, if you need to adjust volume, click on the Media Player widget. When you're done, click on it again to hide the Media Player window. And feel free to customize your webcast console. You can move windows around by dragging on the title bar, or you can resize your windows by clicking on the lower right corner of any window. We welcome your questions about our topic. To submit a question, simply type it into the question window on the left-hand side of your console and hit the Submit button. We'll be answering as many of these questions as possible during the Q&A period, but feel free to send your questions in at any time and we'll add them to the queue and in some cases maybe even try and get them answered during the presentations themselves. Finally, please be aware that today's webinar is being recorded and will be available on the IWC's Urgent Communications website. You will be directed by email about the link to this archive after it's been posted. And now I'd like to introduce today's panelists. Norman Burrows, CEO of Filed Microsystems Limited. Stephen Mackey, creator and owner of Advent Limited. Mornay Stramrud, the senior sales engineer and subject matter expert for TETRA and DMR for Sapura. And to get more information, be sure to check out the speaker bio widget on your console toolbar for further information about these guys. Now let's get this webinar underway. Mornay, the floor is yours.
Thank you, Mr. Donnie. Good day, everyone. We'll start the show off and get things rolling. So what we're going to do today is, at a very high level, compare the DMR Tier 3 and TETRA technologies and kind of give you an idea of the feature sets that are available, talk a little bit about coverage and how these things compare. And we're going to look a little bit at some use cases. Some of them are made up. Some of them are based on real customers. And then we're going to talk, Norman and Steve's going to talk about some DMR and TETRA case studies of real live systems today. So let's start the show with DMR to go first. You know, one of the beauties of having a standards-based protocol for your radio communications is that there's multiple vendors that you can pick from to kind of customize your solution. So you could buy infrastructure from vendor A and use vendor B's mobile radios and vendor C's portable radios if you wanted to. The other thing that helps you is provide you with standard interfaces on how to communicate with the infrastructure as well as communicate with external devices connected to the infrastructure. One of the things, if you look at the list of manufacturers, there's quite a few out there that have got Tier 3 product available today. One of the things I'd like to highlight is, you know, there are a number of manufacturers out there that do trunked type solutions, which are not specifically DMR Tier 3, something like Trunked Turbo. That is a proprietary protocol, NXDN, and IDAS. Those are not DMR Tier 3. So let's go look at, just in a nutshell, DMR has 3 different levels of product that you can get. We've got the professional side of things are covered by Tier 2 and Tier 3. If you look at Tier 1, that's kind of what we would call bubble pack in the industry. And we're not going to talk about that because that's unlicensed bands. If you look at Tier 2, my simple way of looking at it, it's a digital conventional radio. So your standard repeater, analog repeater, but in this case just digital with a digital radio. You still have to select your channel like you would have in your analog system. So none of it is trunked. All the channels and slots are programmed ahead of time. Tier 3 is a fully trunked digital radio. So it's a wide area network with a control slot, typically on your first channel, and channels are allocated by that control channel, and the user can roam anywhere in the system without having to do any scanning or changing of the knobs. That's all taken care of by the infrastructure. Now, Tier 3 is typically referred to as a message trunk system, but there's also the ability by some of the manufacturers to actually do transmission trunked by setting the hang time to 0. It's also a very highly configurable infrastructure in most cases. So let's look at DMR Tier 3 and at a little bit more of the detail level. So the DMR standard is actually designed and was written based on the PMR infrastructure to be able to operate in all bands allocated to PMR, from the 66 meg up to 960. Now that doesn't necessarily mean that you're going to get product for all of those bands, but the spec is designed to work on all of those particular frequencies. It's 12.5 kilohertz channel spacing, which makes for really easy migration from an analog narrow-banded system. In the case of North America, it's a simple exercise of a paper exercise in most cases with the FCC to be able to use the new DMR if you've already got a 12.5 analog channel. It uses simple 2-slot TDMA access, so you get your 6 1/4 equivalency. And in the cases where there are traffic channels, you can use both of those for voice calls. Again, we use 4 FSK modulation in DMR, and it's a very simple modulation scheme, which means that ultimately DMR and analog radios with similar RF characteristics will have very similar coverage and coverage from the system. One thing that's not specified in the DMR standard is the vocoder used, and that's AMBE2+, which I think is the same as P25 Phase 2. It's a very good vocoder for a high compression rate with a high compression ratio, but it's through the DMR Association that most manufacturers have agreed to use AMBE2+ vocoder. The standard allows for forward error correction, which allows obviously when the further you get away from the base station, the weaker the signal quality becomes, or the signal becomes. The system will send enough information for the radio to be able to correct it, and the same for the uplink. So where analog radios would kind of fade away and start getting crackly, on DMR you're not going to hear that, but once you get to the edge of coverage, it'll sound like you're in a waterfall, and then it'll disappear. Very much similar to cellular technology. And another benefit of DMR is that there's a formal interoperability process. I'm not going to spend a lot of time on that through the slide deck, but essentially what that means is manufacturers come together, there's formalized testing, the information is reviewed by an independent third party, and the certificate is issued if it's felt that the testing was successful. All of that kind of stuff is published on the DMR Association website. So let's look at a typical DMR Tier 3 site. So on the right-hand side, you'll see there's a couple of repeaters. That's the 2 big boxes at the bottom. And then there's a skinny little box at the top, and that would typically be your control channel or your controller for the particular site. Now, if you look at if you were to able to visualize the first RF channel, it's divided into two slots. In the case of DMR, the first slot is the control slot, and the second slot would be what we call a traffic slot, and that could be something that will handle either a data call or a voice call. Where DMR is a little different to something like MPT, which is an analog-based trunk technology, the first repeater, only the first slot, is your control channel slot. So you can have a site with 1 repeater on it and have a control channel and have talk paths available. P25, the first whole first repeater is a control channel, and the same with MPT. If you have anything beyond that, then each one of those repeaters that follow on will give you 2 slots for voice or data traffic as and when needed. There's always a back channel with the DMR, one of the beauties of it. Whenever you're holding your press to talk button down, the radio will be able to communicate with the infrastructure, and the infrastructure is communicating back with the radio. That's a key difference between something like an analog trunk technology, where you only really had that back channel to the radio once the radio releases the PTT. So if we look at feature set, the DMR feature set is pretty rich, and you start with the stuff like individual calls or private calls, group calls, so large groups, and the large groups could be spread out over multiple sites, a large region, or it could be system-wide, depending on the application. If it's an emergency, it could go system-wide, so everybody hears the call. Tier 3 has inherently built-in data services that do obviously text and status messages. So text messages is you type in a text message, free-form text. Status messages is it sends a code, and the radio will display the text that's associated with that particular code. There's standards that define what AVL messages look like. In the case of DMR, DMR originally started with their own spec, and then they borrowed the LIP protocol from Tetra and adjusted it, obviously, for the DMR application. DMR allows simultaneous voice and data communications, which is great. If you look at something like an analog-type technology, it's either voice or data. It's not both through the same radio. And then the typical kind of things that you would expect to find in a trunk-style technology. You've got late entry into a group. You know who is talking, who's hitting the PTT button. You can control who accesses the system. And then you can also kill radios that's on the system that shouldn't be there or that you suspect has been stolen. The DMR protocol has an interface or a console interface standard called DMR AIS, Application Interface Standard. And that defines how outside applications will communicate with anybody's infrastructure. So if somebody says, I've got a Tier 3 product, and they support DMR AIS, their protocol will look the same as vendor B, vendor C, vendor D. Now, we also support emergency calls. Encryption is supported in DMR. There's some work groups that are going on to define exactly what encryption is available. And there's also, part of the standard is simulcast operation. Now, I don't think there's many vendors that support that today, but that is part of the standard. So I think the question that pretty much always comes up is, so what kind of coverage can I expect from my trunk system? If I pull out a DMR system, I've got an analog system out there, I can talk for forever, I just bump up the power. Well, with the trunk TDMA-based system, a big part of your limitation is not necessarily the amount of power that you have, but the guard band between those TDMA slots. It's because the information takes a finite amount of time to get to the radio. The radio takes a finite amount of time to process it, and it comes back to the system. So if you do a couple of basic assumptions there, you'll find that DMR TDMA technology allows you around 47 miles of physical coverage, and that's range from the base station. So it's very comparable to analog radios as well as MPT 1327, where you've got, if you've got equivalent RF characteristics. Now, what does that really translate to? Now, I'm going to caveat this by saying there's lots of factors that play into physical coverage, but if you look at what you can expect from it, if you look at a standard portable, 6 to 8 miles first wall indoor kind of coverage. If you're outdoor, you can probably push that to 8, maybe 12 miles. Again, if there's lots of trees, lots of buildings, then those kind of things vary greatly. And if you look at a mobile that's got a bit more power and a decent antenna on top of the roof of a vehicle, you can expect upwards of 40-plus miles from that particular vehicle. So looking at applications, I touched a little bit on the AIS specification for DMR, and part of that piece is, we looked at other technologies, and in the past, and the console part of integration with the radio system was always an afterthought. Now, one of the big things that the DMR Association facilitated was, let's bring in console vendors to help write that console specification, so that instead of having a rack full of interface boxes and cards, they can do a full voice over IP digital interface to the infrastructure. And I think most of the DMR vendors out there do support AIS in one shape or form. Part of that specification is obviously data handling. So if you've got AVL or vehicle location information, that all comes out of that applications interface. So that's kind of the wrap-up for a quick look at DMR Tier 3. Now, next step, I'll do...
Mornay?
Yes, sir?
Hey, we got a question from the audience about the DMR AMBI2 vocoder, and they want a little more information about who was that done through the DMR Association or via ETSI, and also just a little more information about the specification.
Okay, so the easy one is the vocoder is called AMBI2 Plus, as a company called DVSI that actually developed that particular vocoder, and it is all licensed to every one of the DMR manufacturers. The DMR Association, which is in part a whole bunch of different manufacturers, essentially, agreed to use AMBI2 Plus as the standard vocoder for DMR Tier 3, as well as for Tier 2. That doesn't mean that all the manufacturers must use it. It's kind of a gentleman's agreement, and it's not part of the ETSI standard. There are other products out there that are DMR compliant that use a different vocoder. I think of some of the Chinese systems out there that do actually use a different vocoder. What was the other question, Donnie?
Oh, no, they were just was wondering what the specification you went into. It was the 2 Plus, so that's cool.
Okay, wonderful.
So, hey, anyway, thanks for that clarification. Sorry to interrupt.
Nope, absolutely. If there's good questions, let's keep going. So, looking at Tetra, knowing that Tetra has been around outside of North America for quite some time, the list of manufacturers, as you can tell, is quite extensive. There's been a few manufacturers that used to have Tetra product that don't have Tetra product anymore. But looking at that list, most of those manufacturers do infrastructure as well as portables and mobiles. Some of them do gateway products as well, and others just focus on portables and other services. So I'll kind of follow the same route that I did for DMR, and let's look at Tetra in a nutshell. So one of the big differences between Tetra and DMR is the amount of data that goes over the actual bearer, and you'll notice there that the Tetra bearer is actually 25 kilohertz. So it's not a 12.5 kilohertz channel. You do have a 25 kilohertz channel with a fairly complex modulation scheme. I think the native data rate for the bearer is around 38 kilobits per second. That obviously includes everything that needs to be carried over that particular carrier. But that's split up into 4 TDMA slots. So you get your 6 1/4 equivalent use. The vocoder for Tetra is a little different. It's the KELP vocoder, and it's got a slightly higher sampling rate. So the voice quality sounds a little different to the AMBI2 Plus. This one is a little bit more forgiving on the voice, so the quality of the voice for Tetra is typically a little bit better than the quality for a DMR system, the fidelity of it. Now, again, dynamic allocation of voice and data channels as and when you require them. So you could, for instance, have a traffic channel that is carrying 3 slots of data and 1 slot of voice traffic. And if the system gets busy, those 3 slots will be cut down to 2 slots on the fly without any issues. Obviously, your throughput for that data channel will then be a lot lower. Another feature for Tetra, dynamic power control. And that's not necessarily to what a lot of people think about the dynamic power control is to kind of even out the signal strength that the base station is receiving. It's more to control the power consumption of the mobiles and more of the portables, the power consumption, and to extend your battery life. That's where the biggest benefit comes in for the power control. Because Tetra has the ability to do in-call handover, and it was designed to be used in, part of it is designed to be used in urban areas where in-call handover is really important, especially if you turn around a corner of a big building. And, okay. Somebody's moving the slides. Just hold on for a second. Let me get back to my slide here. Okay, so because the system is allowed to do in-call handover, the only way that you can accomplish that is if all the slots on all the sites and the neighboring sites are aligned. So a typical Tetra system will have some sort of GPS antenna connected to all of the base stations so that the TDMA slots for the various sites are in sync with each other. Another feature that is unique to Tetra is the fact that you can allocate secondary control channels. So if you've got a lot of AVL or short data, text messaging and stuff on the system, you don't necessarily want to take that first slot, control channel slot, and swamp it with data. You can add a second or third or secondary control channel slots that will carry that data instead of the main control channel. So typical site, there's on the right-hand side, there's just 2 racks of a typical site. The one is a 4-carrier. We like to call it 4-carrier. It's a 4-channel, 4-repeater site, so that would give you 4 slots for every repeater in there. So that's a 16 slot system. So one control channel slot plus 15 talk paths. Again, the control channel in this case allocates all the traffic on the system. It'll tell radios to move. It'll send out the text messages, all of those kind of things. And in the case of Tetra, this is a message trunk system. Now, you can make the hang time very short at the end of it so that the call will clear, but you kind of give up that instantaneous, when you press the talk, you've got to wait that, couple of 100 milliseconds for the call to set back up again. Typically, the first repeater will be the control channel, and it's only the first slot again that's being used for the control channel. The other 3 slots that remains on that particular repeater can be traffic slots, but you can allocate those for other purposes as well. All of the rest of the repeaters will be traffic channels, and there's 4 slots for each one of those repeaters. The back channel is being used for signaling, so radio can do both voice and data at the same time. And the traffic channels, and something that's probably not being used that much anymore, is circuit switch data, but Tetra does allow you to do circuit switch data as well as packet data on the traffic channels, and those can be dynamically allocated as and when required. So data capabilities that Tetra has, it's got the free-form text messaging. It's got the status messages. That's that code that gets sent over, and the radio will interpret the message for you. Unique feature is the secondary control channels, so you can add additional data carrying capacity to the system if you've got high volumes of AVL and text messaging. There's dynamic slot allocation available, or data slot allocation. So if you need more slots, the system will allow you to use more. If you don't need them all, then they can shrink them down, or the call can get dropped completely. AVL is standard messaging. It's a LIP protocol, or Location Information Protocol, and there's short form and long form of that defined in the standard. So one of the things that really sets TETRA apart from other technologies out there is a mobile gateway. And so I've put on this slide, I've got direct mode and mobile gateway. So direct mode, in layman's terms, is a radio or radios that are not on this infrastructure or not on the system that are just talking to each other. So it's just a couple of portable radios or mobile radios that have got a frequency to them, and they talk in amongst themselves. They're not talking to the infrastructure. Now, that's great if there is no infrastructure available, but sometimes you might be in a fringe area or fringe coverage, and your system was designed to use mobiles, but you want a whole bunch of users that use portables. Now, what you can do in the case of TETRA, with one radio, one antenna, in band, you switch the radio to a gateway mode, and the talk group on the infrastructure is associated with a talk group or a direct mode channel on off the infrastructure. So basically, those portable radios can now communicate via that gateway to a dispatcher, for instance, or to another talk group that's on the infrastructure. This is something that's really unique to TETRA because it's all in the same radio. It's all in the same mobile radio. If you wanted to do something similar like this with DMR or P25, you actually need either an out-of-band radio from a number of vendors out there, and you need a portable that's matching that band. The beauty of using something like this is, instead of designing a portable-based system, you can design your mobile-based system and use mobile gateways and still be able to use your portables on the infrastructure. So, coverage. I guess there's a lot of schools of thought about coverage in TETRA. A lot of information out there. And one of the things about TETRA, a typical repeater site is spec'd as power out of the combiner. So if you see somebody that says this is a 25-watt TETRA radio, it means it's 25 watt out of the combiner going to the antenna. So that would give you roughly about 60, 62, 63 watts going into a combiner system. That's very different to some of the other technologies like DMR and analog stuff, where we talk about the power out of the base station, out of the repeater, not necessarily out of the combiner. If you look at the coverage that you can expect from a TETRA system, notice the numbers are very similar for portables to DMR. 6 to 8 miles for your first in-wall, 8 to 12 miles for outdoor. Again, there's a lot of things that play into it. Geography is one of them. And if you look at the mobiles, yes, the mobiles is a little less. You can expect up to about 30 miles of range on a mobile. And a big part of that is limited by the guard band in TETRA between the different slots. Most TETRA vendors also have receive diversity. So you will have, you've got a transmit antenna, and then you've got 2 receive antennas. And in some cases, you can have an antenna that does double duty. So you've got transmit receive on one and receive only on the other. And that gives you, at least if you've got a good installation with a little bit of separation between those, you can get a minimum of about 3 dB of gain for your uplink, which is real beneficial when it comes to portable coverage. You can also use outdoor base stations. In this case, I've got a picture there of a unit that just literally mounts to a pole, and you can fill in small holes that you might not have seen or that you planned for but didn't have anything to fill them with at the time. So let's quickly step in. I've got a couple of use cases here. They are all based on real systems that are out there, and kind of give you an idea of how to look at a system and make a good determination of whether TETRA or DMR Tier 3 would be a good fit for it. The first one I've got here, you look at it's an 11-site system. It's covering a densely populated metro area, really high density of users, so about 3,000 users over that small metro area or dense metro area, and there's a requirement for data. Tetra is a perfect fit for something like that because there's strong integration with apps and data facilities out there. There's lots and lots of apps out there already, and the voice requirement can be met by either DMR or Tetra. So in this case, it's really the data side kind of leans it towards Tetra. The other side that leans strongly towards Tetra is because you're in an urban setting, having that in-call handover is really important. If you're in a wide area coverage and you're on a mobile and you've got 30 miles range from a base station, in-call handover really isn't that important. So let's look at a transportation one. Integration with real-time passenger information, large amount of location information. Tetra has proven to be a real good technology when it comes to transit integrators. Again, lots of AVL, lots of data, lots of text, and you've got those additional channels or slots that you can use for carrying some of that real-time passenger information. So you can push information out to displays for users. You can grab information from a website, publish it to boards and signs and all of those kind of things. And those applications exist today. So let's look at a DMR Tier 3 use case. In this case, very large system, 100-plus repeater sites. Moderate amount of channels, 2 to 4 channels on average with the sites. Low density of users. Primary use is voice with maybe some odd texting here and there. AVL, so some location information for maybe some of the mobile users out there, but really, really wide area coverage. DMR is a very good fit for something like that because, first of all, every single repeater that you put up will get you 2 talk paths beyond the first one that gives you the control channel. You get wide area coverage, and yes, you get a little bit more range out of DMR. So you'll have fewer sites out in the rural areas. And there's a fairly limited data requirement, and DMRs will work very, very well with this kind of setup. The last use case, if you look at this, this one can go either way. Both technologies have got points that favor them in this kind of application. So you've got, again, 100-plus sites, a mix of dense metro areas with 7 to 8 talk paths required, low-density rural areas with 1 to 2 talk paths required. Voice is primary with some text and status messaging, and there's AVL and a low volume of SCADA. So, but you need that wide area coverage. The key here, the difference between this one and the previous one, is the fact that you've got that high-density metro areas that are included. If you didn't have that, then this would go to lean towards DMR. That high-density metro area gives you the fact that you can use, Tetra for portable coverage within that dense area, and use the mobiles in Tetra with the gateway feature to augment that coverage. So now you space your sites quite a bit further when you're outside of that urban area. DMR will work fine for that whole area. The biggest issue is when you're in that metro area, DMR does not have the handover, so you still have to make sure that your sites are a little bit larger area covered with them. Donnie, I hand the floor over to you.
Hey, thanks a bunch, Mornay. Great job. We are just getting flooded with questions, and I wanted to address a couple of them to you.
Sure, go ahead.
What are the data rates supported in Tetra versus DMR Tier 3?
So native data rates for Tetra, best case, is around 28 kilobits if you concatenate all of the 4 slots together. So each of the slots is around 7 kilobits. That's as good as it's going to get. And then if you look at DMR, it varies, but you're sitting around 2.4 to around 3.5 kilobits per second for a data rate there.
Okay, all right. We have a couple other questions regarding the mobile gateway. So first off, are there mobile gateways available on DMR from Sapura or other vendors and partners?
So for DMR, the answer is no, because DMR doesn't actually have a mobile gateway as in the same fashion as the Tetra standard has defined. If you wanted to do a similar function in something like DMR, you actually have to add another radio to the mix. There's a number of manufacturers out there that do something like that. I think one particular vendor is Pyramid, and they do an additional radio that's, say for instance you use UHF DMR, you would add that Pyramid repeater in, for instance, VHF, and you'd have portable radios that communicate with that Pyramid repeater to be able to communicate back with the infrastructure. If you compare the two solutions side by side, what you find in Tetra through that gateway, you have all your text messaging, all your status messaging, all of your AVL, all of those things are going through that gateway, where if you're using the DMR equivalent, you only get a voice path. So you really don't know, you don't get anything more than that. None of the text messaging or AVL goes through that gateway.
Okay, and then on the Tetra gateway, does that require two mobile units, two mobile radio units per vehicle?
Is that, say that again, sorry Donnie, I missed that.
Does the Tetra mobile gateway require two mobile radio units per vehicle?
No, it does not. It does not. So if the mobile gateway, when you switch that radio to gateway mode, it uses in-band repeating. So if you're a UHF Tetra customer, you would allocate a DMO channel. So it would talk one side to the infrastructure. The other path would communicate with the portables that are still your UHF portables, and they would just use a different frequency in that same block. There's a small number of manufacturers that do gateways. Sapura happens to be one of them.
All right. Well, Morné, thank you so much. That was a great presentation. Take a breath, and I'm going to turn it over to Norman Burrows of File Micro. Norman?
Thanks, Donnie. Hello, everybody. Let's have a look at some case studies for DMR installations then. These are real systems that actually exist. They were all being installed during 2014. The first one I want to talk about was oil refinery, mainland Europe, and what they were anxious to do. They had a number of unique demands. But the first one, I suppose quite a common one, was to double the capacity of their existing frequencies. They had some frequencies that they could call their own, and they'd been using for some years. The existing technology was MPT 1327, but they were finding that at busy times that they were getting a lot of queuing, and they needed more capacity. So going to DMR was a good solution there, because they get an instant doubling of the talk path capacity. It's high traffic volume, so Tier 3 trunking was really the obvious solution there, and they also required emergency calling with preemption. This is an oil refinery situation, and they do have a requirement for mission critical emergency calling. And 3 repeater sites were provided to provide in-building coverage. You can imagine with all the concrete buildings and the metal structures around, coverage was quite challenging there. ATEX radios, of course, throughout, and phone interconnect, both digital and I think also on this one some POTS analog phones as well. The real challenge was that they had to accommodate about 250 existing MPT radios, and a solution was provided for them which allowed them to call seamlessly between MPT and DMR radios on the same system. And when I mean seamlessly, when I say seamlessly, I mean seamlessly. The MPT radio user called talk group numbers and individual numbers that he was always used to, and the DMR radios reacted to that as the number translations were done within the system. So from the user's perspective, it was just like using the radio as he'd always done. He didn't even know in many cases he was talking to his buddy on a DMR radio. So that was the oil refinery case study in Europe. Then we come to nuclear power, an incident reaction system. We are strapped down with the most unbelievable non-disclosure on this one, so I've got to be a little bit careful. But it followed the incident at Fukushima in Japan, and the government concerned was determined not to be caught out if such a situation should occur in their territory. So these systems, they're DMR systems, they're mobile, so they are kept in secret locations and dispatched to the plant concerned when an incident occurs. There is also some part of the equipment permanently installed at the nuclear sites, and the system has to connect together automatically, quickly, and operate as a full DMR Tier 3 system straight away without any time-consuming configuration, etc. They were very strong about voice encryption, so this system had 256-bit voice encryption, which has just about been ratified now in the DMR ETSI committee. So this is a standard feature; it's not a proprietary feature. They also needed high reliability. So the system we provided as distributed processing with dual Ethernet routing throughout the system. Excellent coverage characteristics had to be provided, and again there were big challenges with these huge concrete structures that you tend to find in nuclear establishments. And finally, the system is very modular. So if they find operationally they need to expand the system, or maybe the system is over-provided, they can take channels or sites away and cut it back as they need to. The third of the case studies was the US Army. The US Army had a requirement for communications across various bases that they have around the world, and they have a lot of legacy MPT radios, and if you've got a few thousand radios lying around, you know, that's quite a lot of money lying around, and they wanted to make good use of it. So again, they asked for a system that was MPT and DMR with cross-protocol calling between the two. The system's quite small, one channel of 2 time slots for the DMR part and 2 channels of MPT 1327. Very, very easy to move around, very compact. DMR is great for that because everything's connected by Ethernet, so the wiring is very, very simple. It's very easy to construct and dismantle and change. PSTN and PABX interconnect, again SIP, digital SIP and analog POTS is provided, and they can expand and contract that system as they find they need to operationally. So the configuration and reconfiguration is very, very simple. Okay, Danny, back over to you.
All right. Hey, great stuff, Norman. We do have a couple questions from the audience. Is the seamless MPT that's in the oil refinery and U.S. Army examples, is that a DMR standard or is that a proprietary feature?
It's it's neither. Well, it's not a DMR standard, but what it is it's all implemented using everything which is standard within the DMR environment and within the MPT environment. So in other words, you could buy anybody's DMR radio Tier 3 radio and anybody's MPT radio, and it would work on those systems. There's nothing proprietary about it at all.
All right. And also, does DMR Tier 3 have an interface with PABX, analog or digital?
Yes, indeed. Yes, it's the SIP digital interfaces give you the digital telephony, and there are also gateway to analog phones from that as well. So there's full telephone interconnect features.
All right. Well, thanks a bunch, and thank you to the audience, by the way. We are going to get to as many questions as possible during the Q&A, and we will, if we don't get to them, we will be answering them offline. Our panelists will. So without further ado, Steve, tell us a little bit about some TETRA case studies.
More than happy to. That was a very enjoyable presentation so far, very informative. I want to start out with the utilities that I had worked with. Cobb EMC is Electric Membership Co-op, and so is Diverse Energies is a electric membership co-op. And they're usually the smaller utility companies that have smaller territories, and they tend to work together very closely. And these two membership co-ops co-owned 7 25 kilohertz frequency pairs, and Cobb EMC took the lead during the RFP process. So they had access to both 25 kilohertz and 12.5 kilohertz spectrum. And when we put together the stakeholder team and identified the needs, they decided that they were going to acquire a technology that was digital, IP-based, and standards-based. And they would, and in the RFP, they had put in what their needs were, which were going to have to be met by a industry-wide standard and measured by industry best practices. And all the vendors were told what those matrix were going to be. And when the RFP went out, it encouraged both the vendor community and the consulting community to bring back the best case innovation that they had. It was quite interesting because it was split down the middle between the DMR solutions and the TETRA solutions that responded to the RFP. And there was a learning process for the client or the stakeholders group, because each of the vendors was brought in for a half a day for a face-to-face interview and for them to bring some of their equipment and do a little bit of a show and tell. And it was very interesting in as much as the people that were very engaged and had very interesting solutions, all that would meet the end user's needs. It was very engaging, very educational, and it was interesting because we got a chance to hear the audio quality and a chance to watch the vendors set up their equipment and utilize them within those interviews. And both the voice qualities were quite good. However, the TETRA seemed to be just a little bit better than the DMR. And also the call setup time was a little faster on the TETRA radios. If you look at the A&B vocoder, which is used in P25, the standard in the P25, both phase 1 and phase 2, call for a call setup time that's sub 750 milliseconds. In the phase 2 configuration of the A&B vocoder, they've got it down around 550 milliseconds or less. The vocoder, the linear vocoder that they use in TETRA, has a call setup time of less than 300 milliseconds. And when you're working with high power lines and situations like that are life-threatening, you need to have almost immediate, when you hit the push-to-talk, the ability to transmit and have your voice communications heard. One of the big things, too, with this particular utility company, their need was to have a portable on-the-street coverage. And that's where the diverse antenna situation came about and played a major role. they had the luxury to have 4 sites that they could, in the Cobb EMC, for instance, had 4 sites where they could put diverse receive antennas. We had one that did double duty, as Moni had said, that was a transmit and receive, and we separated that by 16.5 feet with an extra receive antenna, which gave an extra 3 dB on the uplink. And the ability for it to do forward error and correction was quite good. And we were able to cover a 400 square mile area with portable talk-in coverage on a 95% by 95% coverage when it came to doing the drive test. And all the applications and features that were similar to DMR, of course, were also in Tetra, plus a few more. One of the things that the stakeholders group really liked an awful lot was the amount of vendors that they could do business with after the initial infrastructure was deployed. And it looks as if both Cobb and EMC and Diverse will be using multiple vendors for their subscriber units, or what they call their terminals, specifically with the gateways. There's a number of other issues. The ability for a Tetra radio to make a full duplex phone call was something that was of interest to them, because there are a certain group of executives that don't want to carry a radio, but if they need to, they would like to be able to dial into the network and go right into a talk group, and also have some of the radios have a phone number associated with the PABX. And of course, with Tetra, it is a multicast technology. So as you roam from site to site, there is a handoff that's very similar to a cellular handoff, and it's very, very quickly, and the end user doesn't really notice the handoff at all. The idea about that is during a critical event, when there's a tremendous amount of users that could saturate a cell. Another thing that we did during the system design is we gave enough overlap between the sites that if one particular site went down, we might lose some of the portable talking capability, but the mobile talking capability remained the same. So there was a lot of all the cell sites had to be balanced, and we had to be very diligent on how we did the handovers between site to site. It's a little bit different than a simulcast system where you're not really worried about handover, because when you hit push to talk, you light up every single site. Whereas in Tetra, it's multicast. Only the sites that need to come up for that particular talk group, only those sites will be utilized. So it's a little more effective when it comes to frequency reuse plans, because with 7 different frequency pairs, we can start reusing frequencies over and over again. If we had to expand the system to become a 7-site system or a 10-site system, we have the luxury of a frequency reuse plan that will allow us to expand the system as needed in future days. Also, they're going to take their frequency pairs and dedicate it to the mobile gateway operator. Pricing was quite interesting to see the pricing come through. The big differentiator when it came to pricing was basically about the applications. The applications played a major role in the pricing structure, but all in all, the pricing, the delta between the two was surprisingly close. In this particular case, I think what nudged them over to Tetra was the voice quality, the fact that they had 25 kilohertz channels, that they do have a data application other than AVL that they will be using. There was a trial set up to do the SCADA across Tetra using Pegarius's data modem. There is a data modem that is compatible with Tetra that is based on the Tetra standard. And they felt that because they had a dozen or so other vendors that they don't have to stick with the original vendor if need be. This particular system, since it doesn't go over 16 sites, has a distributed logic to it, so there's no expensive central switch. That the positive subscriber list is kept at each base station, and it's very easily remoted. We also use 3.65 gigahertz microwave for backhaul, so we created a very secure walled garden network that could operate under very extreme circumstances. It did not have to rely on any public telephone network or any other public network in order to survive during a critical event. To that end, I would like to answer any questions or turn it back over to Donnie for a wrap.
All right. Well, great job, Steve. And just to clarify again, what frequencies were you guys using?
These are 450. These are 450. The one thing that I didn't mention about the Diverse Power project, that they also shared those frequencies with the local public safety. There was a county that they shared with the police, fire, and EMS, and they are also planning on offering it to the general public as a special mobile relay service as soon as they get the excess capacity on the air.
Okay, all right. And you mentioned the public safety's on there. A lot of people say, oh, well, wait a minute now, public safety isn't supposed to be using Tetra. What are the real rules here?
Well, the thing of it is Tetra in rest of world, in the ETSI world, is the most widely used public safety grade standard in use today and has been around for 17 plus years. Sure. There are no dead fast rules. It seems that politically, when it comes to federal grants, the U.S. government seems to think that the P25 is the technology that favors P25 for federal grants in order to try to create some interoperability. The one thing that we know is that interoperability is not a technological hurdle. It tends to be a political hurdle. So whether you use P25 or Tetra or DMR, and you need to talk to an adjacent agency, if you don't have the same technology, or even within P25, if you don't have the same system key, one of the logical things to do, and I find easiest to do, is that you use a gateway on the infrastructure side to connect to the disparate networks, depending upon how much overlap you may have with the neighboring agency or jurisdiction, depends upon how you configure your interoperability. But Tetra is a public safety grade technology or standards, and actually it has more standards in their suite than P25 does. P25 has about 7 different standards that they work on, which is the Common Area Interface, the ISSI, the console interface, and some of their talk group protocols, whereas Tetra has a longer list of standard-based applications that all of the vendors have agreed upon and work very closely with. And that's why over in Europe, Spain can talk to France, France can talk to Denmark, and vice versa. It tends to be a more accepted and a more interoperable technology. So gateways, I think, in the U.S., because each jurisdiction tends to be their own little island of technology, tends to be the way to have disparate radio systems talk with each other.
Okay. Mornay, aren't there some rules about, in the U.S., that is, regarding 800 versus the rest of them in terms of the use of Tetra?
Absolutely, absolutely. So in the 800 block, like I'm sure most of the folks on the call is aware, there's a particular block that is dedicated to public safety. It's the NIPSEC or NIPSTEC or something like that band, and it's a small little block. Yep, and that block is public safety use only. So Tetra is not allowed to be used in that, but the rest of the 800 block, Tetra is quite normal and allowed to be used, and the same for the UHF stuff. So the only requirement, it doesn't say Tetra can't be used for public safety, it just says Tetra cannot operate in that small little block of the 800 spectrum that's being dedicated to public safety.
All right, all right. Thanks a bunch. And Steve, great job, great presentation. We have got a ton of questions, and we're going to get to as many of them as we possibly can. By the way, I said NIPSTIC, and it should be NIPSBAC.
The one?
On the frequencies. So let's hop into the questions here. Norman, tell us, what is the difference between DMR and NXDN technologies?
DMR is a 12.5 kilohertz 2-time slot TDMA technology, and NXDN is 6.25 kilohertz FDMA technology, which over which is laid a proprietary protocol. It's not an ETSI public standard.
Okay, all right. And another one from the audience, Mornay. Can you define or explain a bit more about what you mean when you talk about the terms handover in TETRA and not in DMR?
Yeah. So maybe I should take one step back. Okay. So because this is a wide area trunk system, and you're assuming that you've got multiple sites in the system, a radio that's not in a call will roam freely between all the different sites, and it'll go from one repeater site to another repeater site based on the signal quality. So that's kind of defined as, I guess the term in the industry is roaming. So the radio will roam to whichever site has got the best quality of service. Now, when you go for something like DMR, if you are in a physical conversation, you're in a call, and the radio will hang on to the site until it cannot hang on anymore, and only then will the radio decide to move to another site. But at that point, the call will drop. So you will no longer be part of that conversation. It doesn't mean that once you've acquired the site and there's a group call that you won't get pulled back in, but your call will drop for as long as it takes you to acquire a new site or a new repeater and basically be pulled into the conversation. With TETRA, there's negotiation going on between the sites. So if you're in a conversation, actively in a conversation, the radio will continue that conversation, and it will move while you're in the call, just like a cell phone being handed over from one site to another. The radio will be handed over to another site, and your conversation will continue. And that's one of the reasons something like GPS sync between the different slots are really important, is so that transition is successful. And from a user perspective, you won't know that you've just been transferred from one site to another. You will hear all the audio that's going on in the conversation.
Oh, okay. All right. Excellent. All right. Another one from the audience. If my agency operates a P25 digital system, how can I talk to supporting agencies that buy DMR or TETRA?
Okay, so there's a couple of different ways to do this. I guess the easy answer is, it depends. It really does depend on what kind of infrastructure they have and to what level do you want to integrate with the neighboring agencies. If it's voice-only communications, then it's a pretty straightforward implementation. You can have back-to-back radios that just hangs off the system. One radio is attached to one particular talk group, the other radio is attached to another particular talk group, and the DMR system and the P25 system, or the P25 and the TETRA system, or TETRA and DMR will all talk to each other via that particular group. The downside of something like that is you lose the ability to know who is actually talking. So you lose some of your data features like talker ID, and a lot of times you also lose the feedback that you get, from having it on one system. You know that the users have actually received the call. If you're on separate systems through a gateway like that, you don't always know that the call was successful on the neighboring system. The other way to do something like that would be through a console, and that's typically how we see stuff like that integrated. So you've got a console, and the console sets up a temporary patch. So one side will be talking P25, the other side will be talking DMR, and the third one could be talking to a TETRA system. And when the agencies have to work together, the console system sets up a patch. But again, it's a voice patch. There's no texting or any of those kind of things going through those particular systems.
Okay, all right. Another question, we talked about pole-mounted repeaters. How are those connected to the system?
You know, they're connected just like an indoor base station would be. You've got an Ethernet port on there, so you basically need an IP-style connection, and that could be provided by public internet provider, a DSL connection, cable connection, or something a little bit more robust like a dedicated microwave link, or if the customer doesn't want to pay for something like a microwave link, they could use one of the small pole-mounted 2.4 gig, 4.9 gig, 5 gig point-to-point links.
Okay, all right. Got a DMR question here. How resistant to multipath interference is DMR at, say, 700 or 800 megahertz?
You know, that's probably a good question to ask Norman.
Yeah, Norman?
I don't think it is, really. I think that's a good question to ask somebody with a little bit more RF experience than I have. Yeah, I mean, that really is a technical question, because you could come up with all sorts of answers to something like that, and I don't have the scientific knowledge to be able to answer it accurately.
Okay. Morné, have you got any thoughts on that?
I agree with Norman when it comes to that. You know, it's very hard to predict what your multipath issues are going to be like. I guess if you compare something like Tetra and DMR, most of the Tetra systems out there have got at least receiver diversity, so your uplink is protected. But downlink, it's very hard to protect that downlink. Being a digital technology, though, you tend to find it's a little bit more robust than something like an analog one, where you might get a hiss and pop to the point where you can't distinguish what's going on. And a lot of times I find that the DMR system will punch through that, and you'll at least get something legible from it.
Okay.
But, yep.
All right. Another question, can Tetra be simulcasted?
Answer is no.
Okay. All right. And for Tetra, how expensive are the combiners, or are they the same as analog combiners?
The easy answer is they're the same as analog style combiners, the same as DMR type combiners. In a lot of cases, the Tetra systems, at least the ones we sell, are prepackaged. So when you buy a Tetra system, you get everything that you need for that particular system. So that's one of the reasons that you'll find Tetra usually quoted as after the combiner. But because it's a digital technology, and we typically look at things that are different. So if you look at an analog system, you're most likely going to find on the older ones N-type style connectors. Those kind of connectors are problematic when you start combining multiple frequencies, especially on the digital stuff. They're a little bit more fussy about it. So we use DIN style connectors on our transmit side for all of our stuff.
Okay. Had a few questions about the frequencies that Tetra operates on, and particularly they mentioned 900. But can you just talk about which are the bands that can be covered with Tetra?
So Tetra actually covers. If you look at worldwide, it's from the low mid 300s all the way up to the high 400s, which is the kind of the UHF block. In North America, it's typically 450 to 470 is the UHF block, and then we've also got stuff in 800. There is a VHF version, a VHF spec for Tetra, but nobody has any product for that, as far as my knowledge is concerned. Everybody's kind of waiting to see if somebody wants to order some equipment in VHF. Okay,
all right. And for both technologies, both DMR and Tetra, what if you were outside the infrastructure footprint? How does everything work?
So if you're outside the infrastructure footprint, if you look at, I'll do the Tetra one first because that's an easy answer. The Tetra radio can operate in what we call direct mode, and what that essentially says is the radios will synchronize with each other. So when you hit the press to talk button, the radio will start transmitting. Radios around it will listen for that, and they'll receive it, and you still have full digital communications between the radios. So if you have encryption, you will still have encryption for that communication. You can still use text messaging, private calls as well, individual or one-on-one calls, just by dialing from the keypad, if you have that, or from an address book. So once you're off the network, you still have all those features. DMR, what we find is a lot of customers actually use the DMR radios in conventional mode. So you still have group conversations for most of those things, especially if it's a tier 3 radio. They would typically fall back to a conventional mode. Have you seen anything else relating to that, Norman, that's different on DMR?
No, I agree with you that generally they fall into conventional mode, or if there's quite a few DMR products which are dual standard MPT, so they may be able to fall back to an MPT system as well.
All right. And we mentioned the bands for Tetra in the U.S. Can you all talk about the bands that DMR is available in?
So DMR currently is available from quite a few of the manufacturers for VHF. I think that's the 136 to like 174. It'll be for some of the UHF blocks, low 400s to probably 470. And then I know about the 800 block as well. So there's products up in 800 for DMR as well. Norman, do you know if there's any other products that are outside of those bands?
No, not at this time, Mornay.
Are there any plans to go to 900?
I imagine it will be driven by demand. Where there's a demand, equipment always appears very quickly afterwards.
That is true, very true. All right. It said, I'm not sure. There are a couple of them here.
So Donnie, there's one question here that I see. It's about the U.S. narrowband frequencies. Low 470. So there's actually, just to clarify, there are some blocks in that 450 to 470 frequency range that still have 25 kilohertz channels. And if you want to use frequencies outside of that, they're a little tougher to come by, and you have to do a little bit of convincing. But a lot of that is farming and working with the FCC. The FCC will give you a license if you can prove that the other channels are not in use, and they will allow you to use Tetra by combining two channels that are adjacent to each other into a 25 kilohertz because of the 6 1/4 equivalent that you get with the 4 time slots.
Okay, all right. I have a DMR question. Norman, can DMR handle conventional analog radio, not MPT 1327?
It depends on the vendor. Certainly my company's product can't at this time. It can handle peer-to-peer if the radio will switch back into analog, into conventional analog, and a few of them will. But again, that's one of those things driven by demand. If there's a demand to be able to have seamless calling between DMR Tier 3 and conventional, we'll sure provide it.
Right.
Donnie, I've got a little bit to add to that. It almost sounds like it's a question similar to the P25, where the infrastructure will accept an analog call. And typically on DMR, the DMR infrastructure is expecting a digital communications from the radio. It does not switch over to an analog mode if it sees an analog transmission.
Okay, all right. Got another question regarding frequency bands. They mentioned that Tetra covers UHF bands like 450 to 470. Does it cover 403 to 430 or 403 to 470?
sounds like it's a Canadian question. The answer is yes.
All right. And is there a logging recorder interface for DMR and for Tetra?
The AIS interface can be used for voice loggers. Typically on the Tetra infrastructure, some of the vendors have got their standard API interfaces that can be used for voice logging.
Yeah, can I jump there, Mornay, that certainly there are a number of vendors that provide voice logging. That's quite straightforward and widely available.
Okay. And what is the standard data packet size that a third-party integrator could use for their own data in a DMR Tier 3 environment?
Well, there are a number of data protocols which are open to on Tier 3, ranging from packet switched IP end-to-end protocols, and it really is vendor specific. The DMR standard only specifies the over-the-air data rates, and as Mornay's already mentioned, you could use the AIS protocol, which is standard protocol, to communicate with the system, and the data packet's going to be quite large, but I'm not quite sure offhand what they will be.
Do you know how many characters is in, for instance, in a text message, Norm?
Text messages are 36 characters on the standard UDT text messages, but of course then you can go to the packet switch data and the other data services if you need longer streams than that.
Yeah. So Tetra has got something similar. The standard text message is around between 120 and 140 characters, depending on the vendor's equipment. And again, you can concatenate them into multiple packets, and also have the packet data sessions or the circuit switch sessions.
All right. Well, we are running out of time here, and I just want to thank all of the first off, the audience. Great number of questions and terrific stuff. And again, we weren't able to get to everybody's question, but our panelists will be addressing them offline. So hopefully we'll get you your answers. We are out of time right now, but I want to thank our presenters, Mornay Stramrud, Steve Mackey, and Norman Burrows for their very informative presentation this afternoon. I would also like to thank our sponsor, Sapura, for making this event possible today. Let me thank you, our audience, for your time and attendance this afternoon, and for all these great questions. We hope you found today's event valuable and informative. Have a productive remainder of your day, and we'll see you at the next IWC's Urgent Communications webinar.